Good afternoon, all.
Good afternoon, ma'am. Good afternoon, all.
Am I audible? I think. Am I audible?
Yes, ma'am. Good afternoon.
Students, any one of you, can you please confirm?
Yes, ma'am,
Yes,
you're
Lord.
audible.
Okay. Shreya, are you here?
Yes, ma'am.
Okay. Um, I think our 6M faculties kindly remind your class students to join. As a last reminder, I have posted the link, but still, please remind them once. We shall start session in a minute or so. Hello, Apurva.
Hello, ma'am.
How are you?
I'm good. I'm good. How are you, ma'am?
Yeah.
Hello, Apurva. This is Amuta, madam. How are you?
I'm good, ma'am. How are you?
Yeah, going on. Thanks for coming in this crucial time of Corona
Yeah.
pandemic time.
Yes,
Okay,
ma'am.
thank you so much.
Yeah.
Monica, ma'am, will be coordinating. Okay, thank you.
Thank you.
Thank you.
Yes, ma'am. Thank you. Um, okay. We shall start the session.
Should I go ahead and present them, ma'am?
Just a minute. I'll give you a formal introduction. Then you can start your presentation.
Sure.
Just a minute. We are still having participants who are joining, so we'll wait for another 2 minutes and then we'll start the session. Uh, Good morning, all. I am Dr. Monica Puttaramaya from Department of Computer Science and Engineering, Sagar College of Engineering. I welcome you all to the webinar today on machine learning projects in industry, a perspective by Ms. Apurva, who is Associate Machine Learning Engineer, ML Engineer from JP Morgan. It's my privilege to introduce our guest today. Apurva is our student as well. She is our passed out batch student. Um so she is a graduate from our department, Sagar College of Engineering, as a 2018 passed out batch, and have been with JP Morgan since then. She joined as software engineer and started working on big data. Work majorly was on Java, Python, on Kafka, Spark with the data ingestion. Later on, she moved on to AIML team in November 2020. Uh, and then she started working on building ML models, data pipelining, performing metric analysis, and productionizing the model in AWS, and so on. It's our privilege to have Apurva here. On behalf of Department of CSE, I welcome you, Apurva.
Thank you, ma'am.
It's over to you. You can start the session.
Yeah, sure. Thank you, ma'am. So, hello everyone. Like ma'am said, my name is Apurva, and I was a pass out in 2018. And even while I was in college, we would interact a lot with the professors and get more insights from them. So I know it would be different now that we are, seeing each other from the screens, meeting each other from the screens. But I would like to say that this is a very good thing that everybody is doing, not just students, the professors as well. I know it's very difficult when you have to manage, coordinate so many things in this virtual environment. A lot is not under our control, but I would like to say that you all are doing a very good job with this thing. um, so thanks a lot to all the professors who were there with us even then and who are there with you now also. And I would like to first pay my regards to all the professors and then begin with this. Okay, so I'm going to present my screen, and in case it looks distorted or something, just let me know. So I hope my screen is very well visible, right?
Yeah, it's visible. There's just a little problem. If you could speak a little bit higher, it's really.
Am I more audible now?
Yes,
Thank you.
thank
Yeah,
you.
yeah. Okay, so let's begin with the current topic for discussion. So ML projects in industry and a perspective basically on that, right? So what would we be discovering today in this session? I would want to take up this session in like two pieces. The first piece would be the ML pipeline. So it is a very common practice that in the beginning, right, when we are starting our careers, all we know is like how to create a model, because we went ahead and did that in Kaggle, or we went ahead and did that for certain projects of ours. Yeah. And then with that skill that we have, the model development skill, we enter the industry, and then we are slightly clueless as to what has to be done exactly with that model now, right? And even the model development is a life cycle on its own. The whole cycle of developing a model is called as ML pipeline. The pieces that we put together and get a model into production eventually, from what was a data to what is now a perfectly working model using that data and actually serving customers in production, is what we would be looking at in this session in the first half. The second piece of it, I would like to talk about certain skill sets that are really important in the industry, something which I have seen around in my company, or I've seen my colleagues from different other companies have. So with all of that knowledge that I have, I have put up a little skill set that is good to have. It's not including just machine learning, it includes the other aspects as well. Obviously, a big chunk of it is machine learning itself, but what other skills would you be needing in the process of, getting into the system? So in the ML pipeline, right? This is a very basic system of the ML pipeline. Uh, as we can see, this is a very general format, and a lot of things always depend on the type of data that you have, right? So let's say you have image data. Whenever we are talking about image data, you cannot go and basically do any normalization on it. Normalization is something which evens out the data. So let's say you're comparing oranges and apples. You would want to compare oranges or apples and apples, right? So that is a very basic definition of normalization. So when we say that this pipeline is very general, it means that there are bits and pieces which will definitely be used in all sorts of the model making, but there are certain pieces which gets introduced as and when your use case changes. If you're working with self-driving cars, right, that would involve a lot of computer vision, and it would involve a lot of unsupervised learning there, and thus all of this changes. So let's begin with the components of the pipeline, right? So the first step of the ML pipeline is data ingestion. So only when we have the correct amount of data in the right quality can we actually begin to work on our models, right? So we all live in a world where data is there everywhere. We all know about big data, right? So even though data is everywhere, even though we have a lot of data, what is the exact data that you would be needing, right? What is the exact type of data that you would be needing? What is the exact quality of the data that you would be needing? What is the volume of the data, right? As we know, big data is actually comprising of three V's: veracity, volume, and variety. So the volume of the data also matters. So let's say you have 10 million records on which you can train your model. Your model training is going to be a very easy task, I would say, rather than you having only like 100 records or 1,000 records, right? Because the number of data, the number of records that you have for your model training are going to impact the type of the model that comes out eventually at the end, right? So the first step is data ingestion, where you would take this data and convert it into a form which is readily usable by you. So let's say we are talking about images, right? So images have to be in a particular size. Your model should not have to look at different pixels at different times. If your images are 200 cross 400, then they should all be like 200 cross 400. If some of the images are 180 or something, right, it will be really difficult for the model output to be in sync with the type of output you were expecting. So that is about the data ingestion, getting the correct amount of data in the right quality into your system. These the type of tools that we generally use, right, when ingesting are something, if depending on the type of platform you are in, right? Let's say you are working on AWS, right? And in that case, your data ingestion would be probably you would keep your data in S3, and then your data ingestion pipeline could include maybe Airflow or something, right? So it would push all your data inside, and then you would have your data in S3 eventually. Now, next is data preparation. And all of this belongs to a part which we call as preparing data. Preparing data, as we said, also includes getting the data inside. So, data preparation. Now, this is the part which we also call as somewhat feature engineering, right? Or pre data processing. So, steps like cleaning your data, steps like aligning your data, steps like finding out what is redundant and what is useful, all of that comes into the data preparation. Once again, it also depends on the type of data you're dealing with. So if you're dealing with voice data, you would not have to do any kind of alignment as such. The major task, the major part of your task would actually be clearing out the noises that are there in the data, in the voice data, right? So after your data is prepared, after your data is ready in the correct format, you would be going and building and training your models. And once you start with building and training your models, that is when you would do your hyperparameter tuning. You would first do an analysis that, okay, this is the type of data that I have. What is the exact kind of algorithm or model that is going to be the most suited for my case? If you have image data, you might want to go with cnn's, right? If you have, let's say, textual data, and the use case at hand says that you have to recommend somebody something, you might want to develop a recommendation engine using the engine algorithms, right? So there is a variety of algorithms available in the market, obviously, and with that, we also get the privilege of choosing all of that while doing the building and training model phase. So hyperparameter tuning, which is basically adding the parameters that will be the most beneficial for your use case. So if, let's say, you're developing a deep learning network, right? And the one basic um, decision that you need to make over there is the number of layers that you want to choose. So if you're choosing too many layers, you might end up making a extremely complex or biased data or biased output with even variance in place. But let's say you have chosen very less layers, right? Let's say you just have an input and the output layer. That is basically not going to give you that good result. If you're using deep learning, that means that you get the privilege of adding the layers in between, and layers are going to simplify the work that you have to put in while doing the feature selection. Next, as we know that you always have to go and select the model. So when I say model selection, it doesn't always means just the algorithm. That is one part of it. So when you have decided that, okay, I'm going to use a recommendation engine, the first thing that you would do is choose a certain hyperparameter and then train your model with the data on it. Now let's say you get the output, but then after you have plotted your graphs or done some kind of a metric analysis on it, you get to know that well, this is not the kind of output I was expecting. Maybe you were expecting a certain a certain row of data to have, let's say, an output of class A instead of class B. So that is when you would get to know that, okay, maybe my model is not performing that well, or maybe my model is taking too much time. That is when you would go back, change your hyperparameters, or try to accommodate more refinement in your model, and eventually that is going to lead into a proper model that is going to be very helpful for you. After all of that is done, we I mean know that obviously the data that we get has to be divided into the training, testing, and validation pieces, right? So when somebody says that, this is the amount of data that you are given, you have to already know that that data is going to be divided into three pieces for getting the best out of your data. So the train set is on which your model gets trained, the test set on which you would be testing if everything is working fine, and before that there will be a validation set on which you will be checking on certain parameters. Once this piece is done, once your model is trained and it is completely built, you would have to you would have to take the model and actually deploy it in production. When we say deploying something in production, that essentially means that you cannot have a lot of errors there. That means that you have decided completely that this is the model which works perfectly fine for me. You have done the testing, you have done unit testing, you have done integration testing with your model. With that done, now you know that, okay, this is the model that is going to be giving me the best result, and it is deployed on a particular platform, let's say AWS for our case, right? For an example, you would go and deploy your model there, and that is when maybe somebody is trying to generate some output out of your model. You might want to expose your model via endpoint over there, right? And as soon as your model has been exposed via endpoint, anybody who is authorized or who wants to use the output of your model can try to hit the endpoint and get the output of it. And that is what we call as deployment. The deployment stage is generally kept as a continuous integration and continuous deployment, so that within a button click, you would actually be continuously doing all the stages that were involved in deploying the model, and that nobody has to go and manually do it. There are instances where these are done manually as well, but whenever we talk about model deployment in cloud or something, right, it is very good if you do it in a continuous integration and deployment way. Almost all the industries have that. Any questions as of now?
You can continue.
Yeah. Okay, so let's continue. Now we'll try to see each of these stages that we just saw into a little more detail, right, with some examples. So preparing data has two pieces, like I said: ingesting, and then you're going into the preparation of the data. So when it comes to ingestion, right, the major job of all the, if you combine all the tasks that are involved in it, the major role that the industry gives these people is called as a big data engineer or a data engineer. So data engineers are people who would know how to engineer your data in the perfect way so that your model can have it a little easier to use, even though they wouldn't possibly do all the feature engineering and things, but they will make sure that your data is present in a good format, that it is easy to read, that it is easily accessible to you in the location that you want it to be, and so on. And the widely used technologies in the data ingestion, right, are Apache Kafka, Kinesis on AWS, Spark Streaming, and these are actually highly use case dependent as well. So let's say my company is using AWS, right? So we might want to use Kinesis Firehose for this piece, and let's say your the in the platform that you're trying to use right now is not AWS, right? Maybe you are given a Unix server, a simple Unix server, or a Hadoop cluster. That is where you want your data to be, and maybe from that point is where you would be running a Spark job, a PySpark job on top of it, and doing your machine learning. In that case, you might want to use Spark streaming. Now, what are these terms exactly? So Apache Kafka is nothing but a mess. You can understand it as a very distributed system. And when we talk about Kafka and distributed systems, right? So distributed systems, yeah, sorry. So the distributed systems are nothing but they are going to help you in dividing the compute and the memory of the load of the model, right? So if you want to run your model compilation, or you want to load your data on a single machine with 100 GB of memory available, with let's say two cores available to you, right? That is different from you having five different machines under the hood, which we call as a cluster in this case. Each of the machine is called as a node. So this cluster that we have, right, where you would be having multiple nodes, this is called as a distributed system. With this distributed system in place, your ingestion becomes easier because each node would be handling like a part of that 100 GB of data. So when we talk about 100 GB of data in five clusters, right, maybe each of the node is handling equally 20 GB of data. Maybe it is not handling equally 20 GB of data as well, right? But at an average, we can at least say that handling 20 GB of data and running compute on it is easier for a machine than for a single machine to handle 100 GB of data and the compute required for it. So Spark streaming. So with Spark streaming, you can if I put it in a very simple way, right, assume that you have a endpoint, right? With that endpoint in place, either you can what you can do is send a file directly to that endpoint, or what you can do is send a file part by part. So if somebody, some of you are already working with web development, right? You would know that there is a type of file, there's a type of input that we generally give here, that which is called as multi-part data, right? And multi-part data is very much useful when you are transferring huge volumes of file. Why so? Because instead of transferring a 100 GB file at once, which possibly your network might even not be able to do, right? You might want to send it in chunks. And when we talk about multi-part data, it actually takes care of it. So if you want to take an analogy, right? So multi-part data or sending data in bits and pieces is what Spark Streaming does for us. And Spark is a very, very powerful framework as well. So it will let you decide your actions, and it will not perform all of them until required. So let's say you tell Spark that, okay, I want to join the rows and maybe perform certain analysis on it, right? It is not going to do all of that unless you ask it to give the result back. So it will perform the action only when the result is needed, and that makes it so fast and so reliable in most of the cases. So these are certain tools which data ingestion uses at a lot of time. And then one example, as I've mentioned, right, that moving data in real time to AWS using AWS Kinesis is what would be the perfect example of data ingestion in our case. Next is data preparation. Now that you have your data ingested in your system, you have to start working on cleaning the data into making it the perfect one for your model to work on, right? If we say, let's take an example that you have a model which is going to understand certain emails and try to make sense out of it, or do sentiment analysis is what the usual term we call as. So let's say you want to perform sentiment analysis on the emails that you have, right? Given that your model needs to read a lot of emails in this case, and each of the emails are going to be of varied length, right? If you're not putting in the cleaned email in this use case, it is essentially going to come across terms like thanks multiple times, maybe because almost everybody writes a thanks towards the end of their email, right? Or regards, or names, or hello is a very common word that is going to be there. Now if you have to take this kind of a data, right, where most of the words are hello, thanks, bye, things like that, it is going to be very difficult for your model to understand which is the exact piece of data that it has to focus on. If you do a cleaning before providing this data to your model, if you let's say remove of all the hellos and the signatures of the emails, and then start doing the tokenization of it, and maybe recognize some parts of speeches, and let's say that your use case needs only the nouns, so you leave out only the nouns mostly in that case, right? In that way, maybe the remaining words in your mail would be, let's say, customer experience, or something like that. The name of the product would be a noun that would be remaining, and maybe all you wanted to do was find out the product that the person is talking about in the email, right? That is going to give your model a better chance of predicting the right kind of product. Or if say, right, let's say we want to do the sentiment analysis on the email. In that case, if the customer is happy or not, right? So if let's say there are words like not satisfied, or if there are words like bad, or if there are words like bad experience as a single term, you would want to consider that in your sentiment analysis rather than going across the whole text. So that is the power that data preparation gives you. It is going to clean out all your data and then leave out only the chunk that you're going to be using in actual training of your model. Again, this is definitely use case dependent. So like we were talking about the example of emails, that is where you would be performing the data preparation on text, or you would be doing this eventually for an NLP model. But if let's say you have images in your model, right, this same kind of cleaning is not going to be required. The kind of data preparation you do on image data would be maybe compressing it, maybe converting it into a single dimension that you want it to be. um, like let's say 200 cross 400 is the type of dimension that you want all your images to be, right? So that would be the kind of preparation that you do. Maybe you want to convert them into grayscale, maybe you want them to convert into HSV, and HSV is hue, saturation, and variation. With this in place, you would be able to get your data into a perfect position where the actual analysis can be done. This will involve sometimes doing the anomaly detection, cleaning data, normalization, and feature selection, as I talked about, right? Very use case dependent. But these are the certain criterias which are generally used in textual data. Also, right, why are we talking about data preparation this much? Why do we want the data to be that good? If I can just go and develop a perfect model, wouldn't that be enough? Shouldn't my model actually figure out these things? Well, there is a talk from Andrew Ng. uh, for those of you who don't know him, Andrew Ng is a very renowned person in the field of machine learning and AI, and he's actually a professor from Stanford. He teaches machine learning over there, and he has created some very very useful algorithms, the state of art algorithms that we are using each and every day in our industry. And the kind of extensive research that he has done has provided a lot to the community. So this is coming from Andrew Ng, who is also the co-founder of Coursera and deeplearning.ai. You would have heard about Coursera, right? There are so many courses available over there. And if you go and search the machine learning courses on Coursera, you'll actually find his courses over there. And those are like the very basic courses which almost everybody is going to recommend you to begin your life with. Now, when if you go and look at this data centric AI video that um, Andrew Ng is talking about, he's talking about how we have to go from model centric to data centric. We don't have to always think about improving our models. If we can improve our data, that is also going to in turn help your model to be improved. That is the basic essence of what he talks about. Just type on YouTube or Google Andrew Ng's data centric AI talk, and this is a very very helpful talk if you want to just go and listen about this and find out more about it, right? So some of the things that you would do in the data preparation, right? For image, let's say you would be doing the extraction of the image. When I say extraction, let's say the example that you want to look into is maybe hand gesture recognition. So there are people who only communicate with sign language, right? um, for them to be able to communicate, they would be doing certain gestures using their hands. And when we talk about these sign gestures and recognition of them, so basically your data is going to be an image or a video with the gestures in place, right? Somebody performing these gestures for you. So let's say you have a gesture being done by let's say me in this frame, right? So when you want to recognize only the hand gesture, if this frame is taken right now, you might want to remove the face, you might want to remove the background, and you might want to keep only the hand gesture so that that can be recognized by a model. That is basically what extraction means, extracting the part of the image that will be the most useful for you, which is what you're looking for. Patching. Now, let's say you were able to extract the hand part in this example, and you have also converted it to black and white because obviously because having a black and white image is going to reduce the time that your model is going to apply on the computation. And like in this use case, right, because it is just a hand and a background, it is just very binary, right? The objects in your image are binary. There is one background and there is one object in place. So if your background is black and your object is white, that is also going to make perfect sense to the model. You do not want to always keep the skin part of the coloring. So if you convert them into black and white, right, there'll be places on your hand where there'll be too much light, where there'll be places where there is lesser light, and that is actually going to give rise to a image which is very distorted. There'll be holes in the middle. When I say holes, because your background is black, right, those little pieces which are black are going to confuse your model, and that is when patching comes into picture. So you recognize the largest blob in your image, and that is going to actually help you fill out those places. With those places filled out, with those black portions filled out, that is what is exactly patching in this whole exercise. Now, dimensionality reduction, as we were talking about earlier, right? Maybe converting all the images into just 200 cross 200, because that also makes sense to you. And then HSV conversion. So, in some places, let's say specifically when you are trying to extract only the skin part of the image, right? HSV helps a lot because when we talk about skin, the skin color is also variable, right? There are darker skin tones, there are lighter skin tones, there are more whitish skin tones, there are pale skin tones. So when we talk about all these skin tones in hand gesture recognition, it might give you a varied sense of image when you convert it into just black and white. So you sometimes want to also go into the HSV conversion in that case. Now let's say if your data is text, again you might want to do lemmatization. What is lemmatization? So if there is a word called meeting, maybe you want to just take out meet out of it. Meeting is as similar as meet for your model, so that is what would be lemmatization, getting the root of the word, lemma of the word. Then TF-IDF conversion, ngram, POS, bag of words. These are all the various um, analysis. These are various extraction pieces that are done on a text. And engrams, right? Let's say a very simple example would be like we were talking about customer experience in an email, right? So let's say you are always going to have customer and experience together. Now telling your model that customer and experience are different words is one thing, and telling your model that customer underscore experience, let's say, right, is one single word. So whenever we say that customer underscore experience is one word, that becomes an engram. So converting n number of words into a single token for your model to analyze better, for your model to understand better, is what engrams would do. Then I have just, for the sake of examples, mentioned a series of steps that I used for data preparation on a recent project that I performed on. So this was for doing some kind of a recommendation actually, where I was going to eventually give out the classification of the cases. You can understand it as, let's say you want to take certain emails and say it is a fraud, it is a non-fraud, something like that, right? So this is a classification problem, a binary classification problem. In such kind of a problem, I mean, that is not what I was doing, but then obviously because there are things which cannot be revealed always, let's consider that as an example. And these are the steps that would be very helpful when you would be doing the classification. So I had to do data cleaning, and then I had to do NA data handling. When I say NA is not applicable. So if any of you are using Python, right, you would know that whenever the rows or the columns of your data are empty, right, Python sometimes tries to convert and write it as NA. And not always, but sometimes this happens that when you're using pandas or numpy, right, in your model preparation, you might in your data preparation, there are cases where pandas or numpy will fail because of any data being there. So you might want to convert them into let's say -1 or 0, if that is not something which makes a different sense in the model, right? If let's say you are going to predict the output as 0 and 1, you can definitely not convert your NA as 0, because that will make a different sense for the model. You might want to make it -1 in those cases. There are some cases where you want to entirely delete any rows. So that is one part of the data preparation. And then I did the continuous and categorical data separation. Continuous data is nothing but your numerical or decimal data, which has a continuous range. So you cannot very well say that there will be a particular category to which my data is going to belong to, right? And categorical data is generally string in very simple sentences, right? So let's say you have the categories, which are cities in this case, right? Let's say, right? If you're talking about one column as address, the categories would be the cities uh, for some cases. In that cases, that will turn out to be a categorical data. So separating the data into continuous and categorical is something I performed there, and then I had to do feature selection. So a very simple example of feature selection would be, let's say your data has address, and let's say your data has age and it also has date of birth, right? So having date of birth and age both in the same data are not going to make a lot of sense. You choose one of them and leave out the other. So that is going to help you understand which are the features that your model has to focus on. Having a lot of data is good, but having a lot of data is also not good. So your model might get confused as well. There'll be a lot of variance in your model. Having lesser data might lead to bias, but having a lot of data might lead to variance as well in your model. And then I had to go, and because I was creating a deep learning network over there, I had to create an embedding layer for the categorical data. So embedding layer is nothing but, if let's say you have A, B, and C categories which are only present, maybe your category A is going to be termed as 1, maybe your category B becomes 2, and maybe your category C becomes 3. So that as soon as you convert them into numbers and maybe do one hot encoding or something, it is going to be converted into zeros and ones. So wherever you have the category A, it is going to mark as 1 in your data, something like that, right? So that is going to be very useful. And after that, I had to divide it into train, test, and validation set. So this was the major part of data preparation I did some time back. Any questions at this point of time? No? Okay.
Apurva,
Yeah, sure. Yes, ma'am.
we'll have question and answer session in the end, so you
Okay.
can just continue. Go ahead.
Okay. No problem. Fine. So let's talk about now actually building your models, right? So most of the time, what you have to do is, after you have seen your data, when you start doing the data preparation, you meet the data exactly, right? You understand what it is trying to tell you, what all the data has to offer for you. Let's say you want to create a recommendation engine, right? You have to be sure that everything required for your recommendation engine is provided by your data or not. There are algorithms which will need which have certain prerequisites, right? Let's say there is some type of an algorithm which needs your data to be in a tabular format. Now if your data is not in a tabular format or something, maybe that algorithm is not going to do the best work for you, right? And that is when that is the most important part, where you have to actually perform the algorithm selection. You find out, you go out there, read out a lot of papers, you do some kind of a research, and you come into a conclusion that, okay, because these papers are using the similar kind of data that I have, producing the output that I would need, which will be the most beneficial for me, okay, this is the kind of data that I'm going to be using, and this is the algorithm with that which is going to do the best job for me. Now, like I said, first is the algorithm choice. Second would be probably, you if you're going to use deep learning network, right? The very basic and the first choice that you make, and which is going to impact your output as well, is the number of layers that you want to add. So I also mentioned this earlier, right? So if you have too many layers, it's going to lead into making your model extremely complex for no reason at all. If it is too less layers, it is also not going to help a lot. The rule of thumb, which many people use when they are not really aware of what to do, is have a single input layer, have a single output layer, and have a one single hidden layer as well. That is going to do the job for most of our cases. Then, if you have to go with unsupervised learning, right? We all know there are multiple types of machine learnings that are possible, multiple categories. One is supervised learning, then is semi-supervised learning, and then there is unsupervised learning. So when we talk about unsupervised learning, right? A very simple way to understand that would be to take an example of a self-driving car. So when we talk about a self-driving car, um, let's say Tesla, right? It has been trained on a certain road structure. It has been trained in a certain parts of the US, let's say, or maybe in any other country as well. Okay, in other continents also probably it has gone. But when they have to launch it in Indian market, do you think they would want to first run it here and then get a better idea and only then they can launch it? No, they'll still come here, they'll still launch it, and Tesla is still going to work well with us, right? Why? Because it is unsupervised learning. It does not need you to give that good data set for it to learn from. It is going to learn on its own as it is working. So because this Tesla has been trained on certain roads, it is already knowing that how do I have to navigate on the road, right? Just as a normal human driver would do, right? You might have gone on maybe a mountain or something, right, once, and that is what is going to give you the experience to maybe drive on other mountains as well. Sorry. There'll be some pieces that you have to keep in your mind. Let's say that if it is raining, I need to keep my speed low, but if there is sand, I have to be very careful, and things like that. So that is something the model would learn on its own when it is driving on the roads. That is unsupervised learning. The problem with unsupervised learning is because it is unsupervised, right? Sometimes you just do not know the behavior of these models. So it is always recommended that you try to make unsupervised learning as at least semi supervised learning. What is semi supervised learning? The same example of a self driving car, right? Let's say that unsupervised learning is when the car is driving on its own, and it basically has no idea what is right or wrong, right? It only probably gets to know something is wrong when it crashes, right? Then there comes unsupervised learning. If you try to introduce unsupervised learning in this car, right, what would that mean? That would mean that maybe a human is going to drive that same self driving car, and the car is going to learn from the human driver. What do I do in certain scenarios? That is semi supervised learning. A human involved in the loop of the learning is called as semi supervised learning. Now, result analysis. That is a very big part of model training. After you have created your model, after it is generating you proper results, right? How do you know that is the exact kind of result that was needed? Well, that you can identify based on the scores that you get, right? Maybe you calculate the mean square error, maybe you try to calculate the mean of all the values and see that, okay, this was the expected mean and this is the mean that I have got now. That is where most of the statistics comes into place. So there's a lot of statistics involved when you have to eventually try to analyze the output of the model. And after doing all of this, maybe you want to automate your inference and the metric analysis. So let's say every day you're going to get 100 GB of data on which your model has to give an output on, right? If you're talking about a very well industry setup, that is what happens with us. We would train a model on, let's say, 1 TB of data or something, right? And then the work that the model does every day is inferencing on that data. So every day, let's say if the customer data is coming in, let's say KYC data or something, right? Or maybe the emails that we were just talking about some time back. So every day when those emails come in, you would have to run your model so that it can do an inference on it. And only then that output, on top of it, you would be doing some kind of a metric analysis, right? Let's say you want to calculate the mean of everything, or let's say you want to calculate entropy out of it, the bits of knowledge that it contains, right? And with that, you would be knowing that okay, this is 1 day worth of work. Now let's say you have to do the same inference running your model on 100 GB of data every day. Well, keeping a human to do that is not very wise. So what industries generally do is create a pipeline, make it continuous integration, as I was talking about earlier. So when continuous integration is done, we create a simple pipeline. um, Very common example of pipeline tools in this case are Jenkins and Travis. So almost everyone uses Jenkins or Travis in the industry. With these tools, you can do this in an automated way. So what the pipeline would do is, let's say your data is arriving at 6 p.m. every day, right? It knows that at 6 p.m. I have to check in S3 if my data is there or not, or whatever is your source. From the source, it sees that okay, I have got the data. Now I have to run the data preparation. I have to clean the data. I have to get the data ready. Now I have to run an inference on top of my model. Remember, it would not train your model because your model has already been trained. You don't train your model every day, you run inference on it every day. And you would run an inference, and then your output comes in, and then on your output you would perform some kind of a metric analysis. And with all of this completed, maybe you want to expose your result to a dashboard or something, right, where users can see okay, these are the pie charts, and with that they can figure out what is going on exactly. So that is the automated way of inferencing. Unit testing, a very important part, which if you do not do, you might suffer a lot in the production environment. So whenever we talk about unit testing, it means that you take a chunk of code, a unit of code, and see if it is performing in the way it was intended to. So let's say you're doing a feature analysis, right, or feature selection process, or there is a piece where you want to, let's say, do the categorical data or embedding. Let's say, right, we were just talking about embedding. Let's say there is a piece of code which does embedding. Now if you get to know in your production that on a certain day when the data had let's say special characters, right, the embedding just stopped and everything is failing now. Well, that is not what you want, right? You would have to do a unit testing before sending everything to production, and that is where testing comes in hand and is very, very important part of the pipeline. After your model has been built and you are very, very confident that okay, all the testing has been done, all the analysis has been done, and that okay, my model is going to be very good performing, you would have to take your model and deploy it like we were talking about. Okay, the first thing that you would do is choose the platform on which, right, let's say you want to deploy on cloud, or maybe you want to deploy on prem. When I say on prem, it is on the servers that your company has. So maybe your company already has servers, right, and they or let's say they have Hadoop clusters. So that is where you would take your model and deploy it probably. Let's say your company has moved to cloud, or they're using Azure or GCP or AWS for that instance, right? You would have to know the place where it is best suited that your model resides in. Once you've chosen that, you would have to choose the tools in that particular cloud or on-prem which are going to support you, right? So let's say you have to run a real-time model. When I say real-time model, I mean that somebody has a dashboard. What they do is maybe they type in some text. That text goes into your model, and your model does some kind of recommendation on top of that text, let's say, right, and it returns back the result. That returned result comes and it is displayed on the screen for the user. Now this was in a real time, right? As soon as the user typed in the text, they got the output back from the model itself. So this is the type of scenario that we are looking into, right? In this case, maybe AWS SageMaker is something you want to go with, because SageMaker helps you deploy the model and it creates an endpoint for you as well. So and it is going to take care of all the compute and memory under the hood. So you don't have to worry that okay, I have to create EC2 instances, or I have to create load balancers, or maybe I have to create something else under the hood. SageMaker is going to take care of all of that. It is going to do the scaling for you. It is going to make sure everything is running all the time, and you know take care of doing all these bits and pieces for you in real time. So that is the choice of the tool that you want to use in this case. And then you have to build a deployment pipeline, like how I mentioned, right? There are Travis, there are Jenkins. These tools are available in the market, and generally these two are very important for any company to run a proper pipeline for this deployment. Monitoring and alert setup, a very important feature. And like I was mentioning, right, if something happens for your model in the production, how would you even know that okay, this is not working fine, or let's say this is giving me out errors? Maybe when your model inference ran, it gave out an erroneous output, and as a developer you might want to get to know every time it is doing that, right? So you also know that okay, my model is not working on these cases. Maybe I have to go back and look into retraining it, or maybe I have to do a better feature engineering on top of it, right? So these things are possible only when you have alerts and monitoring setups. And we all know how much important this is for debugging purposes, right? Whenever something goes wrong, you always want to take a look at the log. Only when you take a look into the log, you would know that okay, something has gone wrong and where has it actually gone wrong. So obviously, monitoring and alert setup is extremely important. On AWS, we use CloudWatch generally for this purpose, and it is provided by AWS, and it is a very good monitoring setup. Now, the log setup, obviously, as I talked about, and resiliency. Now, when I say resiliency, right, if your model is the one that we were talking about, right, the real time, you hit the model and get the output back. Sorry. So let's say your model is the endpoint which is exposed from SageMaker, right? Your model being resilient means that it should be able to handle hundreds of requests or thousands of requests at the same time, if that is what is expected out of you. If let's say your customer base increases like exponentially, right? Maybe it goes into a lack of customers using your model at the same time. It should know that okay, I have to scale up. Maybe I have to bring in more EC2 instances and get the inference faster, and that is what resiliency is. So you have to plan for resiliency. You have to plan for the fallback plan. So let's say everything that you have planned does not go as expected, right? Maybe your model is not giving out the intended result. Maybe it is not able to handle the amount of data that is coming in, data that is flowing in. Maybe it has started giving the response back in 1 minute, and that is not possibly what the user wants. The user wants a response in 1 or 2 seconds. What do you do then? You would have to have a fallback plan as well. You would have to have a previous version to which you can go, or you need to know that okay, these are the things that I need to do, these are the set of steps that I need to take care of as soon as something fails in production for me. So that is all about the machine learning pipeline. So these are the steps that we would generally consider when creating and deploying a model in production. Now, the skill sets that I was going to talk about, right? As we saw that these are the various components of a ML pipeline. So obviously, right, if we are saying that maybe your company, the future company that you're going to, is going to use GCP, Google Cloud Platform, in that case it will definitely be beneficial for you to know GCP, or at least to know how things work in cloud. That there is a possibility of having a load balancer which is going to take care of everything, and that it's not always a human that has to take care of it, right? And all of that comes if you know these things. So these are certain skills that I found which were useful and always good to have in a machine learning practitioner. So the first one is data engineer, which is the person who would be working with the big data ecosystem and doing the data ingestion and preparation also sometimes. So data engineer is the person who would be doing the data preparation. Data scientist is somebody for whom the one that is highlighted, researching, and I have marked a star. So researching is the most important aspect of being a data. If you're not able to research well, if you're not able to read through like 10 papers or 20 papers of a single algorithm which are talking about the multiple ways of executing a particular thing, you would not be able to go very well with with the model development, right? Well, if somebody has only 2 years of experience as well, the experience would also matter there. But if that person with just 2 years of experience is also able to read and understand what these research papers say from the very state of the art algorithms, right, you would also be able to develop as good a model as them. Then Python and statistics is obviously, I mean, Python is just a language. It's something which most of the data scientists use, but that doesn't mean if you don't know Python, you cannot do this. Even if you know Java, even if you know Ruby, even if you are good with Go language, even if you are good with R language, anything is good for you. Language is just going to be, certain syntaxes and certain rules that you would have to understand. But like as we have seen, right, in the recent years, most of the data scientists have picked up Python as their go-to language. Linear algebra. Now, this is one skill which is the most underrated skill, I would say. When I joined my team back in November 2020, the first thing that my manager told me was go and revise all your linear algebra concepts and statistics concepts, because this is something we use day in and day out. Be it creating a model, be it analyzing your data, be it analyzing the result of your data, because eventually everything is going to be around the data, right? It's on the data that everything is going on. Linear algebra and statistics are the core of machine learning. It's just that how the core of computer science is data structures and algorithms, right? If somebody is not very good with understanding the data structures or algorithms, they might find it very difficult in the later stages when they have to go and build production ready systems which are resilient as well, right? So this might come into your mind sometimes, right? Why am I being even taught about this graph structure? Graph is very complex data structure usually, right? But now that I'm in the industry, I know that graph is something which almost everybody is looking for. Graph makes your work so much easier when it comes to machine learning as well. You almost always end up creating a graph for many use cases at the same time. So linear algebra and statistics, do not underestimate them. If you want to build a career in machine learning or AI, definitely go and conquer these two, statistics and algebra. I would repeat again. Then data analyst. For being a data analyst, essentially what you do is the first part, right, where you are preparing the data, or the last part where you have got the output and now you're analyzing, okay, what does this mean eventually, right? Or what graphs can I create out of it for a better representation? The business or your product owners would not be knowing what is going inside the model, right? Even if you go and try to talk to them in these jargons and try to explain them, let's say TF-IDF or something, they wouldn't want to understand it. So the way to go about is using statistics and putting your result into a more pictorial or graphical way, which will be more representational, as we say. Now, model deployment. For model deployment, you would need to know the cloud and the toolset knowledge. Now, when I say toolset, this is very specific to each company. So, some companies have their own clusters, right? Some companies have created their own in-house tools for doing certain things, right? Maybe from maybe they're using C, C++ in the backend, and because C, C++ is very, very fast, maybe they are not even wanting to use Python, and that their framework that they have developed is even faster than the frameworks available outside. Or maybe they just want to be very cautious of the security or the sanctity of the data that they are having or their customers, right? In those cases there will be specific tools related to your company, but something which is going to be definitely the tool which is going to remain for a long, long time in the market is cloud. You would have heard it from your professors, you would have heard it from your colleagues who are your friends who are there in the industry. They would always tell you to go and study for the cloud. It could be any cloud. I mean, you need not go for only AWS or GCP. You can go and study Azure. Azure is very widely used. Um, there's IBM Cloud, there is DigitalOcean, there are many other clouds now available, tool sets available. Now, to gain these skills, these are certain resources that I always find useful. So, the first one is Coursera courses. As I was saying, right, Andrew Ng has co founded Coursera. So, if you go and search for Coursera, you will find a bunch of courses ranging from the beginner to the advanced level for machine learning. There are also courses in association with multiple universities. Like I just came across this course where University of Arizona State has partnered with Coursera, and they're offering a course here in Coursera. There is University of Michigan, there's University of Washington, um, a lot of universities. This course itself that I have mentioned, right, the machine learning and deep learning courses by Andrew Ng, are partnered with Stanford for most of them. So Coursera is having a lot of courses out there for us. YouTube. So YouTube is free and available to everyone, right? And Coursera is going to cost you some amount of money. That is the course, right? If we talk about YouTube and the channels that are most useful for us, Three Blue One Brown is like the best channel out there for linear algebra. If somebody had told me earlier that linear algebra is something you should know and go and maybe look into the video of Three Blue and One Brown, I would have done that almost every day. I would say they're so good with the explanation, and I mean, you have to just watch and know. It is very good videos that they have out there. Luis Serrano, so Luis Serrano is also somebody who is working with machine learning for a lot of time. I personally went ahead and studied LDA, linear Dirichlet analysis from him, and linear Dirichlet analysis is a very, very complex topic, which I mean, if you try to read a paper and understand or something, it is going to be extremely difficult. But Luis Serrano made it like look very, very easy in the way he has explained. So Luis Serrano is another person I would recommend. Steve Rudon, I mean, definitely go and check out his channel as well. And there are many, many more channels out there. Once you start looking into these channels, right, there will be recommendations coming in just right below it. And almost all those channels are as good as possible. Khan Academy and Free Code Camp. We have always had this habit of underestimating the free stuff, right? So Free Code Camp and Khan Academy both are available free, and that is the main reason why they have been overseen by so many people. Khan Academy is so good for statistics if you want to start, and even if like you are into researching and developing your models, my manager still goes and checks out the Khan Academy videos sometimes when he's working on it. And when I say my manager, he's somebody who has been working in the industry for 15 plus years in data science. He's a lead data science in my team. So if they still have to go and focus on Khan Academy videos sometimes just to brush on up their skills, well, you should definitely start if you want to move forward in this path. Now, O'Reilly is a platform which is going to give you notebooks and sandboxes. So it is a different thing when you see somebody type the code or you read somebody's code, but it is a different thing when you practically go and start doing it. So there are notebooks available on O'Reilly which also have certain use cases defined before them. So and there are sandboxes as well. So let's say you want to go and start working on something and
Hi Apurva, we can't really listen into you.
hello.
Yes, you're audible now.
I'm sorry. Okay, I think my internet broke down. Could you please let me know which point of time was I inaudible from?
Just a minute back.
Okay, cool. So, okay, so like there is Udemy for all the certifications, right? So let's say you are good with model development and everything, and then obviously when you enter the industry, you would have to deploy your models as well. You would have to work into setting up your AWS architecture completely, and that is when would come in hand all these certification programs that Udemy is providing. It's going to help you get those certifications. So let's say there is somebody who has already a cloud certification on their resume and somebody with not a cloud certification. That is going to make a little impact when they also are looking into differentiating you with somebody else. So this always helps. Now, I've just added this last slide here, which is what ML at JP Morgan is. So, the AI head at JP Morgan is Aposh Saxena, who had joined us from Google in 2018 right now. And I mean, if you go and type on the internet, right, you would also get to know what Omni AI and you know es- just the work that we are doing in AI in JPMC. um, there's a big misconception sometimes, that JPMC is a bank. I mean, what would you be doing eventually with the AI? But we are actually exploring a lot. There are so many teams out here. um, Not just the single team that I work in is working on machine learning. There are at least 50 more teams who are working on machine learning and AI. And almost all of them are falling under Omni. So Omni means all, and this is a in-house tool of JP Morgan. This is actually available on our portal called JPMC Insight Technology. So if you were to look into it, you would get to know that how we are actually trying to change the face of AI in our environment, how we are trying to involve ethics and remove the bias along with this, and how fraud detection and maybe document analysis, smart documents and things like that have come into picture, and how we are working on it essentially. And the use cases that we work on are like very wide. We work on deep learning, we work on NLP, computer vision, almost everything you would name out there. The general positions that we have in JPMC for the ML practitioners is data scientist, applied AI ML engineer, which is the position that I am in right now, data analyst, data engineer, and there are technical managers, and so many other positions out there. There are research positions, and JPMC has a lot going on with AI as well. So if you want to just go and give it a read, right, you can visit this insight and technology at JPMC, and that is going to give you a little insight on it. Yep, that's all I had. Thank you, everyone. I would like to open the line for questions. So there are no questions, or like everybody is really shy. You can all ask, I mean, whatever you have in mind, no problem.
Hello.
Yeah, hello.
Yeah, my name is Chetan and I'm from sixth semester. I didn't have any doubt about any topic you explained. You did it really well. I just had a doubt about placements.
Okay.
What do we prepare for it and what are they expecting? Because being
So,
in sixth sem, ours is like next.
right. So, when you talk about placements, is it that you're aiming at a particular company or like in general you're talking about?
In general, for someone who doesn't have a particular aim.
Yeah, okay. So, whenever we talk about placements, I think the first thing that any company would look into is your algorithms and data structures. So, definitely go practice on Hacker Earth, Hacker Rank. There is Lead Code, which is very, very widely used by a lot of companies out there. And with the practice that you have of the DS and algorithms, you'll be very good with the understanding of the subject. And these two are almost always asked in your interviews, and not even like right out of college. If you I mean, you would have obviously heard when you go to companies like Amazon, Google, um, Apple, they always focus on your algorithm and data structure skill. Now, saying is easy, go and learn algorithms and data structures. How do you actually do that, right? That's when comes into picture your portals like HackerRank, HackerEarth. So, Lead Code is a little more different. I mean, obviously, Geeks for Geeks and these places are there, but Lead Code is something which is the most standard that most of the people in NA refer to. North America, I mean. So, if you have to just begin with it, I would recommend using Hacker Rank. They also have a big chunk of questions around them. They give you badges after you have finished certain levels, and that is going to show up, I mean, in your profile as well. Try to incorporate good communication skills, because those are also going to be impactful. So when you're, even if you have studied a lot of data structures and algorithms, but you're not able to communicate it to the interviewer, and they are really not able to figure out what you're trying to say with your code, that is also going to be a little, difficult for you. So that is one thing. And then I think there are GD rounds also sometimes for some companies. So that is where you might want to, do some kind of a reading and prepare for those debates and things like that. And it's not entirely a debate in GD, but you always have to be like cautious of the tone of your voice and things like that. So, yeah, I mean, most of the interviews are around these things. Prepare your resume very well. I think that is one thing which is going to help you get started. So, resume is the point where anybody is going to see who you are, right? The company doesn't knows who you are. So, as soon as they look into your resume, they should get a reflection of you. Try to not make it more than one page. If it has to be, keep it 2 pages, but definitely not more than 2 pages at all. Does that answer your question, Chetan?
Yes, yes. Thank you.
Thank you.
Hey Purva, my name is Dimant and I'm from 6M. I wanted to ask you if you could tell us a little more about your resume going into JP Morgan before that, if that's
Okay.
okay.
So when I was in college, you mean?
Yeah.
Okay. So let me see if I actually have my resume around here. I can just pull it out. So I was like, I mean, I know that there are some instances where we don't know that, what has to be done in life and things like that. But I was a little more sure that I have to like go down this route only, that I have to, pursue computer science only. It was always like my dream or something. So with that, I actually began my career, and I I'm not sure if this is updated or this is the one in college. Yeah, this has a little job experience section, but I mean, this was not there earlier for me. So this is the resume that I had created for myself. You should always kind of try to mention all your GitHub and LinkedIn profiles. If you have a profile in HackerRank or LeetCode or something, right? CodeChef, definitely try to put it out there. Recruiters find it good to know that they can go and look at your projects right here. And the usual mentioning of the qualifications, and like I was saying, right, the technical skills. I think this is the most important section that falls in, right? So while I was in college also, I mean, all the professors would know this thing. Krishnan sir was actually my guide for the final year project, the final year project that we create, right, in the seventh and the eighth semester. So while I was in college, I was in also this place called MIL Lab. I don't know if it has been renamed or something. Purnama ma'am and Rashmi ma'am were the in charges there. And I was like kind of always interested in this field, right? So I had a lot of side projects in my resume. My GitHub had certain projects, and it's not that I did a lot of internships or something at that point of time, because um, I know now the college is actually autonomous, but our batch was the last one which was non-autonomous, the VTO affiliated one. So what happened was that we would get only a month of break between our semesters every time. It was not a 2 month break for us at any given time, right? And it is always difficult for recruiters to keep somebody for just a month, right? If you're available for 2 or 3 months, they would get more work done from you. 1 month is probably something you will need to understand their ecosystem. So not a lot of internships as such, but yeah, I did have a good amount of projects because it was my interest. I kept doing certain projects in and around the areas of interest that I had. So I primarily worked with Java. I knew some Python, and now that I'm in my ML team, I use a lot of Python. I was also very active in web development, so I built certain web apps while I was there. Hackathons is something which obviously is like my go-to place always, all the time. And hackathons give you a very good exposure also. Like, you get to meet other people, you get to know what other people are doing. Only when you talk to somebody, right, who is also exploring the arena like you would get to know that okay, they are working on this, and maybe I should also try to work on it. Or maybe on a hackathon, you saw somebody win some prize, and when they were explaining their use case, right, you found it very interesting. And that is where your interest lies. These are the places which will always tell you that okay, this is something I like and this is where I want to head into. So web development was one thing which I was doing. I also made some Android applications back in college. Um, we also launched the application into Google Play Store. I'm definitely sure it's not even up and running now. But yeah, that was something we did in around second year of our college term. And if we leave about this part, so this is my final year project, Kalpaita, a machine learning approach to interior designing. There is a little YouTube video also available which we made. So what does this do is you would speak out the description of the room. So let's say there is a table and a chair, you say, and the system is going to render a 3D image, a 3D view of that scene that you just described. And it would also let you do certain modifications. So that is one thing. And then
Actually,
something,
Apurva, if I can kind of interrupt and add a little bit
sure.
about your project interaction, guys. Actually, there were four of them actually. Apurva with Ashish and Aishwarya and Karthik. All of them were very self-motivated, and I would say they were one of the very enthusiastic project teams that I have interacted with. All of them. See, generally in a team there will be one or two who is very motivated, others less motivated, etc. This was a team where all were equally charged up. They wanted to do a great project, and they didn't choose a simple problem. They chose a little bit of a complex one, and they went about it in a very good way, and it was a pleasure interacting with them and guiding them through that. And they were always like looking for what else can we do, and where do we publish it. That kind of a learning drive should be there. I think this team was exceptional, and as it will have it, all of them are doing very well. I think two of them are in JP Morgan, along with her one more person also there, and the two of them have gone for higher studies, completed it. So that self drive and motivation, I think they had in abundance. And Apurva, if I remember correct, your selection itself was based on a hackathon, right? That was the first time the recruitment was changing also. For their batch, I think JP Morgan conducted an open hackathon where they teamed up with people from other colleges. Can you a little bit elaborate on that selection process, Apurva?
Sure. Thanks a lot, so for your kind words first off. And I would definitely like to mention this as well. While we were doing this project, right, this extremely complex looking project, I'm not going to lie, it is complex. And when you start doing it, you'll get to know how difficult it is. There were times when we wanted to drop it all together, when we wanted to, go to Krishnan sir and tell them, sir, it's not happening. So, but then we somehow found the courage to come back. And I think that is what always helped us. And obviously, there were times when we were not sure what is next step, and we would just go to Krishnan sir and then ask him, and he would guide us always. So coming back to the point where the recruitment, so JP Morgan conducts a hackathon called Code for Good every year, since I think 2017 or something. And the recruitment that we do via that is based on a hackathon. So the way it goes about is, you and other people from all the colleges around the country, right, are coming together into a place. And the opportunity that you get there is that you will be teamed up with people whom you have never ever seen. So talking about my experience, I was teamed up with 5 other people, and each of them were from a different college. Like, somebody was from VIT, there was somebody from Bangalore Institute of Technology, there was somebody also from I think Thapar University in Punjab. There were people from IITs, there were people from NITs. So all 6 of us had no idea, who we were and what we knew. It's only like when you're applying, after the interviews are completed, right? They would ask you to fill in a little form where you would mention what are the skills that you have, and they will try to team up everybody into a team where everyone has, a little bit of skill that would be needed for the hackathon. Now, why do we call it Code for Good? Because this is where NGOs come in and they will give us their real life use cases, the real life problems that they're facing. And then you would be given a proper presentation by everybody after you're teamed up, after you've interacted, and you will get a chance to interact with the NGOs as well. So now this is something which also happens in real life, right? You would be in your company or something, and you would be given by your business team that, okay, this is the problem we are facing every day. Now, if I remember correctly, the problem case that we picked up from our NGO was that the NGO was for people with autism, children with autism. And then when somebody is living with autism, it is not very easy for them to grasp things, right? So whenever they are taught, maybe typing in the letters, that is also very difficult for them. So that was their whole use case. They wanted us to make it easy for them to manage their children who were in their NGO with this autism. So we came up with with all 6 of us thought about it, and we came up with a platform where the user can go in and they can actually get a screen where there'll be a keyboard, and we will just let them type something, and we will tell them that, okay, this is the correct thing that you're typing, or no, go back, and this is what you were supposed to type in levels. And the good factor about it was, I still remember there was a team which added this feature where you know seeing those little awards is always something which makes us happy, right? So they added little awards to every level, and that was a plus point for the winning team that I'm talking about. And in the application that we were building, we tried to add in face recognition. So I mean, doing a normal login is difficult for normal humans with the captcha and everything coming in from Google, right? And imagine the scenario for people with autism, right? It is even more difficult, especially when you are building a app where trying to teach them to type. You cannot expect them to do the login for you. So that is when this idea came to us, that we'll add in a face recognition, and the login will work from their face recognition. And I think that was something which I was working on, and I still remember the mentors that keep coming in from time to time. They were very as astonished that you're trying to actually accomplish a face recognition in like 2 days. It wasn't something that I was coding from scratch. So there is library called Kairos, if I remember it correctly, and that is what I was trying to use. That framework was going to help us with this thing. So things like these, right? When you're motivated, when you understand your problem statement, always help you in putting out a better solution for people. Like in the hackathon that we were going into, the best part that is of the code for good, right? First thing, you're teamed up with people who are not known to you, and that is practically going to happen to you when you land a job, right? You would be paired with people in your team who would not be known to you. Secondly, you would be given a problem statement just the way Code for Good also gets from their NGOs. Number three, you would also be doing the same kind of a analysis. You would try to get in the technology that is possible for you. You'd be using GitHub. You'd be using proper presentations in place. And with all of this going on, there are multiple mentors that keep coming every minute, every hour or so. So the good part about this is there are multiple mentors. So it is not the perspective of one person that gets a team to win. There are multiple people who give their outputs, and then everything is, consolidated. And with the consolidated census of all the mentors, all the SMEs that are around, they come into a conclusion that okay, these are the people whom we found the most efficient, whom we might want to get into JPMC and have them work for us. So that is how they hired us in this Code for Good drive. Yeah, so that was the Code for Good drive. And then as you can see in my resume, right, this is the Android application that I was talking about. We always kind of were motivated from our professors that it's good that if you want to showcase something. So how would a recruiter know that you have actually developed this and it is good, right? So if you have like a working example showcase somewhere, let's say you develop a website and have it hosted somewhere, that is, and provide the link to your website here in your resume, that is going to let your recruiter know that okay, if I go and click on this, I'll be able to see a real functioning website, and that is going to give them more idea of what you are doing. And this is something which I did. I always try to mention the role that I had, right? Because sometimes this happens when your recruiter is trying to ask you questions in interview. Now let's say they saw this work of mine, and maybe they started asking me about the UI components, right? Now that I have mentioned that I was a backend developer, they might not ask me the UI questions, right? Because that is not something I might be familiar with. So this is for your own good, adding your own role. This is something which I figured out would be good enough, and I added it. And yeah, most of these projects were made in one or the other hackathon. This was a side project which I did. This was the final year project. This was in so Star is a app which I developed for the International Women's Hackathon. I and Varsha Jambunathan from our college, because this was a women's hackathon, just two of us went and participated in this in, I think, 2017 or something, around the beginning of the third year. And this was a good application that we were able to build. And I tried to mention certain publications, internships, and awards that I had. So this is the same final year paper that Sir was talking about. We got it published, and definitely some of the things that I did, and then always mention the participation. So it's not always important that you get an award. So like I was able to go and participate in Hack to Help, which also tells that I was a part of a good hackathon. And LinkedIn's Winterthon 16, this was the first year LinkedIn hosted a hackathon, and I think only around 30 people from the whole country got a chance to get selected there, and I was one of them. So it's always good to mention certain things, certain accomplishments. And then certifications and workshop, this is one course which I had done from Udemy in college, and I have not updated this definitely with all my other courses. So yeah, this is mostly what I had done in college. Not a lot has changed in the projects and other sections. I think this this resume is definitely made when I was in the first year of my job. Yeah, this is what it looks like.
Hey Purva, my name is
Hello,
Chitraksh. I'm
hello.
from sixth semester.
Mm-hmm,
So I had one question about the Code for Good.
mm-hmm.
So once you have been divided into teams, how long do you have until the actual hackathon begins? Because I'm sure you'll need to plan, right? Like what type of technologies is comfortable with everyone.
Yeah, so I think we reached around 12ish and or 11ish, I would say, and the hackathon began right after lunch. So it was 1:30 or 2 when the hackathon began, and it ended around 10 o'clock the next day. 10 o'clock in the morning. The presentations actually began around 8 as well, 8 itself, along with the breakfast. So, I mean, there were team because there are so many teams, right? And judges would come to like one team at a time. So it's not that there's only one judge, there are multiple judges, but they kept coming to us. So we were told that, okay, this is the time slot at which during which the judge is going to come to you. So 2 to 8 is the basic time that we had, and we met each other around 12. So this is I mean, like you were saying, right, we need to know the skills that others have. So this is something which I did for my team, just to know what everybody knows. So I went ahead and added a little post-it. These little post-its are there, right? So I just carried this with me at that time, and in one of the posts that I just started writing the text tags that everybody might have. So everybody just went in and mentioned it, because it's not always that everybody is comfortable writing that what they know, or speaking about what they know. They cannot like, in given that only 1 hour or 1.5 hour is there for you to begin, before you can begin the hackathon to interact with each other. This is something which I tried, and it kind of helped us. So based on whatever was mentioned in that post, that we just started giving each other the allocation of work. But yeah, it's not that you have only that much of time. You can always do this, right? That you all sit together and just give a informal introduction of yourself. And when you're introducing yourself, just mention what all you have worked on, and what are your strong points. When you know everybody's strong points, you can definitely allocate work very well.
Thank you, Purva.
No problem.
Hey, I'm sorry, I had one more question.
No problem.
Since you were doing a presentation at ML, my question was, how likely is it for a fresher to get a role in such technologies like AML, cloud, or IoT? Is
Good
it
question.
so?
Yeah.
Would it be better for us to prepare for these technologies, or would it be better for us to allocate more time for things like DSA and OOPS?
um There is no direct trade-off between the two, I would let you know. So, whenever you're a fresher, right, the companies that come to recruit have their own plan of recruiting you, and I mean, if it is like in my case, it was a hackathon, right? They saw us do the thing. It was not that we just mentioned on the resume and that's it, or they were asking us questions, which, we might have memorized and told them. They saw us actually working on spot there, and they saw that how much, we are struggling and how we come out of this struggle. And that is the most important thing for them. Because of this hackathon, they got to know. Now, when there is no such kind of an interaction, right? When there is a one-to-one interview that happens, which is the case with most of the recruitments, right? Let's say your recruiter comes in and they definitely have your resume, right? So if they see there that you have already mentioned machine learning or something like that, they would ask you questions related to that, obviously given that they know about it. But if a company is going to allocate somebody to interview you, they would generally allocate somebody who knows the skills as so they can ask kind of a relevant question. Now, the two things that you talked about, DS and algorithm and your specialization, right? DS and algorithm is the first step to get a interview done. So even for Code for Good, there is a round now. There's a first round where you will be given on a particular day, you'll be given a link, and there'll be actual coding questions which you go and complete. So if you do not have any experience with DS and algorithm, you wouldn't even be able to pass the first step. So DS and algo is the base of any interview. That is mostly the first round in almost all the cases. Once you have cleared it up, only then can you proceed and go into your specialization. So it's not that you're in sixth semester or something right now, right? Maybe fourth semester, let's say. So you do have certain amount of time, and it is not that you have to dedicate all your time to DS and algorithm, or you have to dedicate all your time to ML. You can continue working on your ML projects, but just make sure, like, then maybe 2 or 3 problems I have to do in a week in Hacker Earth. That will give you the, I think, the needed amount of hands-on on your DSL algorithm. So yes, both are important. One is going to let you pass the first round of interview, and only then will you be able to show the second skill. Also, you were mentioning in the very beginning, right? How much is it likely for you to get a role of an ML practitioner? In my company itself, I know many people, many interns who are coming in, and because they have a ML background, the company is always thinking of the use cases that are there with them. And they then, because they find somebody who has the skill, they're going to give you that project to work on. So this is about somebody in in my office. So that person joined in from Bits Pilani, and he was an intern. So when he started interning, because he had the machine learning expertise, the managers showed interest in giving them the project of their level. And with this project that he had, right, he actually developed a very good system. And then when he got a full-time offer from the company, right, they moved him into a machine learning team itself. So that is how he got aligned into his area of interest. So it's not that companies are not going to give you the kind of expertise you have, especially in drives like this, right, where everything is general, where you're just entering. They look at your skill sets. So if your resume is mentioning you're good at Java, they obviously will align you to a team who needs somebody who's good in Java. If your resume says you're good with machine learning, they will align you to a team which needs people in machine learning.
Thank you. That helps a lot.
Yeah, no problem. Any other questions you would like me to answer?
Any other questions? Students, please feel free to ask Apurva. So
Hello,
thank you very
Apurva.
much, Apurva. Yeah,
Hello, Apurva.
yeah.
Sorry. This is Aditi. I just wanted to ask you something like, as you showed in your resume, you had a lot of hackathon based projects. What if somebody does not have hackathon experience, but they are doing their own projects and internship based projects? Will that add to our resume?
Definitely. I mean, if you are creating something and you're putting it out in GitHub or creating and let's say you're creating Android application and you've deployed it into Google Play Store or something. Well, end-to-end completed applications are always good. So, I mean, hackathon projects are worked on for like a month or something at max. Like after you've finished your hackathon, you would work on it for like a month or something, right? And then you would might be taking up another project. So internships and the projects that you're doing definitely add on. Make sure that you push everything into GitHub so it is in a, a central repository. And whenever you give a link to your GitHub, right, that way the recruiter can go in and actually see what all you have done, and your code base is actually visible to them, right?
Thank you so much. Actually, the thing with my case is I'm working for an internship with the
Mm-hmm.
image classification and all,
Mm-hmm.
intrusion detection system and all. Thing is, I have signed an NDA with them, so I
Mm-hmm.
cannot present my projects to GitHub or anything. So how should I mention it? Like I have
Okay.
asked permission from the recruiter. He's told me you can just mention in a in a weak way that you've done it. You have an
Right.
experience with it.
Right. So where I had a job description or job experience mentioned, right? Similarly, you might want to put an internship experience, or you can also call it job experience, right? And just mention it was an internship. And there, almost every company is going to have this policy. You can definitely not take their code and put it out anywhere. I mean, not almost every company will do that unless it's a startup and they like allow you to do something. All their code bases are their own. So how do you mention in your resume? So I think because this is something which I did here a bit, so I just vaguely mentioned, right, that framework in Java which automates and facilitates the data into the architecture from RDBMS, highly configurable data quality engine in Spark and Oracle, and then worked on these technologies, built a file ingestion platform using Spring Boot, Python, Angular, sorry, and then a Unix-based framework for Flask. So, like this, if you just vaguely mention, right? Now, let's say somebody is really interested in knowing what went behind the scenes with this, right? Or let's say somebody wants to know what did I automate. They will pose a question to you in the interview, and then without revealing the confidential detail, you should be able to answer them. Like, just let them know, right, that
If there
this
are
is something
no
I
more
did.
questions, I think we can call upon Shreya to give vote of thanks. Shreya?
Hello everyone. I would like to conclude this session by presenting vote of thanks. I would like to thank our speaker, Ms. Apurva Jaiswal, for visiting and enlightening us with her knowledge. Today's webinar was full of knowledge and interesting things. It gave deep insights into the topic and also revealed some interesting facts. The point where Ms. Apurva told us about her final year project was really
Apurva, it was a very nice presentation, a nice interactive session. Thank you for your well spent time. It's very nice, well prepared presentation. Thank you so much. Formally, our student is ready to give vote of thanks. Over to her. Anything you would like to share, Apurva?
No, I mean, obviously, I was able to interact very
You
well.
are on mute. I am unable to hear, Apurva.
We can hear you, Apurva.
Yeah,
Yeah, tell me,
clear
tell
it,
me.
clear it. Yeah.
Okay, yeah. So
So
nothing
from
much.
my side also, thank you very much, Apurva.
Thank you,
for
ma'am.
your valuable time and valuable inputs to the students. Thank you so much. Anyway, the student is ready to give the formal vote of thanks, please.
Yeah, thank you, ma'am.
Yeah.
So, yeah, I mean, obviously, it is always good to come back and talk to all the professors, and obviously, it is a new batch of students every time we come. I still remember, like, before COVID began, I think 4 months back or something, I had once, just came to college to meet everybody on a Saturday, and we interacted with the professors, and there was some event going on in college. I don't remember exactly, but we also got to, interact with everybody over there. Because I was also right there where you are few years back, I can tell you that one major piece of advice, if somebody had given me that time, would be first don't be shy or afraid of exploring new things. You might be hearing some buzzwords around you, but it's not that everybody is going to be very well suited for that particular stream or something. You should always try to do what works the best for you. So, try to explore something, try to explore what is working best for you. Try to see if you're very good with machine learning also, right? Try to see maybe if you want to expertise in NLP, if you want to expertise in big data, let's say, or maybe you're just very good with designing the UIs. So go with your plus points. They will definitely give you a more stable career, I would say. And don't be afraid to explore, like I said, even after you are in your career, right? Like I was when I was in college, I did have some experience with machine learning, but not like on a industry level or something. I hadn't developed something which would be so industry intensive. So I had more experience on Java, and when I joined the company, I started working there. And then because I was so interested in the projects I got, right? I kept interacting with my leaders and managers and told them that, I'm really passionate about these things. And slowly, and they started giving me more work. When they gave me some work and I executed it properly, they saw that, yeah, this person had the potential. And if you anyway, put out what you know, what knowledge you have, and if somebody is seeing it, they will appreciate it. So don't worry that what will happen in future. Do your best. Do what you love. Try to explore more. Don't think that, okay, I'm in my 10 years from now on or something, right? Let's say you're in a career and you're very comfortable doing something. Don't be afraid to move to the next step of your career. Yeah, thank you.
Monica, ma'am. Monica, madam. Hello, ma'am.
Yes, madam. Yes, madam.
Ah,
Yes,
yes,
ma'am.
ma'am. That, yeah.
Hello,
Should we
everyone.
wind up the
I
session?
would
Yeah,
like
please.
to
Yes,
I would
sir.
Please go
like to
ahead.
conclude
Please
the
go ahead.
session.
Yeah.
I would like to thank Ms. Apurva Jaiswal for taking out the time from their busy schedule and enlightening us with the knowledge. Thank you so much. I would like to thank our principal, Dr. CPS Prakash sir, and vice principal and HOD of Computer Science Department, Dr. Ramesh Babu sir. I would also thank Dr. Amuta S. ma'am, the professor of Computer Science Department, and the coordinator of Computer Science Department, Dr. Monica P. ma'am. I would thank ACMW and Vindhya ma'am too. I want to thank all the lecturers being a part of this session. Also, thank you to all the students present here for paying your attention and learning. Thank you.
Also, one thanks to Dr. Krishnan sir for referring speaker for today's speaker. Thank you, sir. Thank you all.
Thank you, everyone. Thank you, all the professors and students. See you guys soon. Bye.
Thank
Bye
you.
bye.
Bye. Bye bye.